Welcome back, everyone. Today I'll be doing partial differentiation where I'll be looking at the second partial test. Now, the partial test is done to determine if it's a minimum, a maximum, or a saddle point, or if the test fails. So what I like to do is to let A represent a partial derivative with respect to x twice. This is a second derivative. And let B represent the partial derivative. I'm differentiating y twice. And let C represent a partial derivative where I'm differentiating the next function twice, but I differentiate with respect to x, then with respect to y. Based on my assignment, then for it to be maximum, when I substitute A and B minus squaring of C, if it is greater than 0, it can either be a maximum or a minimum. To determine if it's a maximum or a minimum, then if A is less than 0, then we say it's a maximum. But if A is greater than 0, then I say it's a minimum. So both maximum and minimum has to satisfy this condition where both has to be greater than 0 when I substitute. After doing this, if A is less than 0, then I say it's a maximum, and if it is greater than 0, then it's a minimum. If it's a saddle point, then we expect that this is less than 0, meaning I am getting a negative value. But if it's equal to 0, then we say the test fails. Let's look at an activity. For this example, it states find all critical points for the function and fxy equal x squared plus y squared. So if you realize I have the variable of x and a variable of y, and classify each as a relative maximum, relative minimum, or a saddle point. First, it asks for the critical points. So I have to differentiate with respect to x. I'm differentiating with respect to x. It means when I see a number that stands alone, or I'm seeing a variable y, because I'm differentiating with respect to x, if I'm seeing the variable y, then by itself, I know it's going to be 0. So differentiating x squared, I will get 2x, and y squared, because it's by itself, that is why it will be 0. Now I'm going to find fy. What happened is that because this doesn't have a function of y, it will become 0. But this part, when I differentiate it, it will become 2y. Now, to find the critical points, I equate 2x to be equal to 0 and solve. So I divide both sides by 2. So x is equal to 0. Same thing with 2y. I have 2y is equal to 0, and solving, I divide both sides by 2. This cancels, so y is equal to 0. So the critical points, x is 0 and y is 0. Now, after doing this, I need to test, is this critical point a maximum or a minimum? That's what I need to find out. Is it a maximum or a minimum, or a saddle point, or the test fails? So I need A, where A represents fxx, and I need B. B represents fyy, and I need C. C represents fxy. So to find A, I identify that this is fx, and I differentiate this to get 2. fyy, so I identify fy and I differentiate 2y to get 2. So in other words, for fxx, I differentiate this with respect to x once more. That's why I get the 2, and I look at this. Because I need fyy, I differentiate this once more to get 2. Now, fxy, I'm hoping you're saying that for fxy, we're going to go back to here, because It's saying we differentiate with respect to x and now with respect to y. But this doesn't have any y, so that is why I will just have 0. So now to substitute to test what is happening, I will substitute in this ab minus c square. A is 2, b is 2, and c is 0. So 2 2's 4 minus 0. So that gives me 4. So that tells me that this is greater than 0. As we know, if it is greater than 0, it can either be a minimum or a maximum. So what tells me is the value of A tells me whether it's a minimum or a maximum after getting this part to be greater than 0. So since A is equal to 2, that is greater than 0, then my conclusion is that it's a relative minimum. So 0, 0 is a relative minimum. The next question states, find all critical points for the function fxy equal 12x minus x cubed minus 4y squared and classify each as a relative maximum, a relative minimum, or a saddle point. Once again, I need to find my critical point. So I need to find the derivative with respect to x. So doing this, I will differentiate 12x to get 12. I will differentiate minus x cubed to get minus 3x squared. And then because this doesn't have a variable x, it is like a constant, so it will become 0. So I will not write it. For fy, I am going to differentiate with respect to y. So this doesn't have any y, so that's 0. This doesn't have any y, so that's 0. And differentiating this, I will get minus 8y. Now, the next step to find the critical points, I need to go ahead and solve. So I have 12 minus 3x squared. And remember, critical point is where we have the maximum, the minimum, the saddle point, and it's at 0. When it's equal to 0, that's when we have that. So that's how we equate this to be equal to 0 and solve. So carrying this over, I will have 12 is equal to 3x squared. And then divide both sides by 3. So this cancels. 3 to 12 goes 4 times. So I have x squared is equal to 4. To get rid of the square, I square root both sides. So x is equal to plus or minus 2. So I have two values for x. Here I have minus 8y equals 0. And solving, I divide both sides by minus 8. This cancels, so y is equal to 0 divided by a number. It doesn't matter if it's positive or negative, is 0. So what this is saying is that for x is positive 2, y is 0. And for x is minus 2, y is 0. So we have two critical points. And now we're going to test, are they maximum, minimum, or saddle point? That's the next step. Now I need to find A. A is fxx. B is fyy. And C is fxy. Once again, we are going to look here. Fxx means I differentiate this function with respect to x once more. So when I differentiate 12, that's 0. When I differentiate minus 3x squared, that's going to be minus 6x. So A is equal to minus 6x. The next is B, fyy. And I differentiate this once more with respect to y. So that will give me minus 8. The final one is C, where I differentiate with respect to x, then y. But I already have with respect to x, so I just need to differentiate it once more with respect to y, but there's no y here, so therefore I will have a 0. No. Substituting, I know it's going to be AB minus C squared. Now, remember I'm testing 2 points. So I will be focusing on when x is equal to 2. So A is minus 6x, B is minus 8, and C is 0. Now x is 2, so I replace x to be 2 here and multiply. 0 squared is 0. So now multiplying this, you can see that I will get a positive number because negative times negative is positive. So minus 6 times 2 is minus 12, but times it by 8, I will get minus 8, that will get 96. So this is telling me that it's greater than 0. Then I focus on A. A is minus 6x. And once again, because x is 2, I replace this with 2. And I am able to see that this is minus 12. So what does the minus tell me? That A is less than 0. So when A is less than 0 and this is greater than 0, let's look at the chart here. It's going to be a maximum. So that's what it's telling me. So that's what it's telling me here, that for this, it's a maximum. Now, I'm not through because I have to look at when I have x equal negative 2. Now, for x equal negative 2, I replace A. So it's going to be minus 6x. B is still negative 8. And then my C square is 0. So I minus 0 squared. Now x is minus 2. So when I put a minus 2 here, negative times negative, that's positive. So this will be positive 12 times negative 8. So for this, I will get negative 96. Now, when I have a negative number here, it's telling me that I will have a saddle point. It's a saddle point because it's less than 0. So we don't even have to go any further because once we have it being less than 0 for this part, that's it. We know it's a saddle point. So for this, we know it's a saddle. So remember, I had substitute A to be minus 6x, B to be minus 8, and C to be 0. But when you substitute x to be minus 2 times minus 6, that's positive 12, times minus 8, that's negative 96. And here, automatically, I don't have to go any further because once it's this part, which is AB minus C squared, is less than 0, then it is a saddle point. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, leave a comment below. Have a great day.